Okay, we've been working a lot with scale factor, and most of us have gotten the handle of finding scale factor of two different shapes. And I'm just going to show us real quick. Here's an example. If we've got a shape that is 2 and 4, and I've got another shape that is 4 and 8, I'm going to always start by labeling, but I'm just going to remind us real quick, we want to see how we got from one side to the other. So 2 times a blank space is equal to 4, and that blank space is represented by my scale factor, and 4 times my blank space is equal to 8. Well, that's great, and we know how to do that, and in this case we can look and go, well, 2 times 2 and 4 times 2 give us our answer, so our scale factor was 2. In this case, it works really easily. But sometimes we end up with scale factors that don't work out quite as easily, with some numbers that are maybe a little bit harder to find those scale factors for. And so let's take a look at what we're going to do when we end up with shapes and numbers that we can't use quite as easily. So in this example, let's start with the same shape. We're going to start with a rectangle that's 2 by 4. Again, I'm going to always make sure that I'm labeling that at the beginning. And then I'm going to look at a similar shape, and I'm going to tell you right now that this is a similar shape. And I'm going to try really hard to make this good on this iPad. It's a little bit hard. But this time we're going to make it 2.5 by 5. So you can see on this side it's just a little bit bigger. And on this side it's bigger by 1. Okay. Now in this case I could still do the same thing. I went from 2 to 2.5. 2 times something is equal to 2.5. I could also do the same thing with my width of my shape. 4 times something is equal to 5. Well, that's good, but I don't know my own self. I don't know what number magically fits in that spot, because 2 to 2.5 isn't a math fact that I've ever learned. So what we can do if we run into this problem is we can remember that multiplication is the opposite of division, and division is the opposite of multiplication. Therefore, I can take both of these problems and I can work them backwards to solve for my blank space. So in this case I'm going to start with 2.5 because I'm working backwards. 2.5, and I'm working my way backwards. So this is going to turn into, it is right now multiplication, but it's going to turn into division because I'm doing the opposite direction, so I have to do the opposite operation. 2.5 divided by, and if I'm continuing to work backwards, now I just do my last number that's there, and that is going to give me a 2. So 2.5 divided by 2 is now equal to my blank space. I could do the same thing with my other number working backwards. I would have 5 divided by 4 is equal to my blank space. Now in this case, I understand some of our division is a little bit tricky. If you're not really good at division yet, we're going to be working on it in a couple of weeks. Don't worry about it. What I want us to focus on is, can we set this up? Because once we get there, we can use a calculator to help us right now if we're not as good with our division facts. But can we set this problem up correctly? Can I go work backwards to set up this problem? That's what I'm looking at right now. Okay, so if you ever run into to similar shapes that it's kind of hard to find the scale factor for, it's really important that you take that and work it backwards. Can you work it backwards in order to find that missing shape? And in this case, we certainly can. Let's do just one of these. I'm going to choose the bottom one. I'm gonna choose 5 divided by 4. Let's do that on the other page real quickly. And I'm going to actually set this up as a fraction because I like to work with fractions better than I like to do long division, though we certainly could do this with long division. All I'm going to do is I'm going to ask myself, How many times does 4, our denominator, go into our numerator without going over? 4 goes into 5 one time without going over. And that leaves me with 1 left over and a denominator of 4. The denominator always stays the same. So I end up with 1 1/4, or oops, not 2, 1.25 as my scale factor. So I could come back in here and fill this in with 1.25, 1.25, or 1 1/4. I could use either of those. And I could do the same thing here, 1.25. And in fact, if you were to go and check, you could see that 2 times 1.25 is equal to 2.5. And 4 times 1.25 is equal to 5. So you can see a way to find scale factor when scale factor is challenging to find.